Hello, and welcome to Palisade Corporation's webcast, Decision Analysis and Statistics for Decision-Making using StatTools 5.0, presented by John McKenzie, founder and president in Novastat Corporation. My name is Jameson Romeo Hall, and I will be your host today, and I will be available to help answer WebEx technical questions by chat. If you experience technical difficulties joining this WebEx session, please dial 1-866-229-3239. Alternately, you can email technical questions to support@webex.com. At this time, all attendees are in a listen-only mode. Please note that as attendee, you are part of a larger audience today. The attendee list is suppressed to maintain attendee privacy. We will be holding a Q&A session at the conclusion of today's presentation. You may ask an online question anytime throughout the presentation today by clicking on the question mark icon located on the floating toolbar in the bottom right side of your screen. We invite you to sit back and relax and enjoy today's presentation. I would now like to introduce your presenter, John McKenzie. John, in a moment, I'll pass the WebEx ball to you.
Okay.
And you now have control.
Okay, well, Jameson, thanks very much for the introduction. I'm here in Boulder, Colorado, and you know, we're having the Democratic National Convention in Denver. I haven't veered down there to actually look at myself, but just watching on TV. But anyway, I would like to, my talk is on data analysis and statistics for decision making using StatTools.
Oh, John?
Yes.
You can click your Quick Start tab.
Okay.
Sorry to interrupt you.
Okay, sorry. Well, let's see where we're going here.
Oh, sure.
So, Quick Start, okay. Quick Start,
Yeah.
And then share your desktop?
That's correct.
Okay.
Okay, go ahead. You were saying about the convention?
Okay. Are we on now?
We're on.
Okay. I'm sorry. So now I can share my desktop. Okay, cool.
All right. Looks great.
All right. Sorry about that.
Oh, that's fine.
Okay. So anyway, I'd like to tell you a little bit about Novastat and, you know, what I do and how I got involved with this risk analysis. Novastat, what we do in our company here is we provide consulting and education and risk and decision analysis. And one of the things that I like to work on are natural resources, that is water and ag. And kind of our mission is to stomp out statistical illiteracy and what I call numeracy, because, you know, when we make decisions out there, especially in the policy arena, a lot of times there's no model behind it, and we don't really look into risk. So we do these classes, I call them the soft skills, and they're not quant classes per se, but they're very important. But in addition to these soft skills, we offer what I call the core skills. One of the classes we do is this data analysis and statistics for decision making. And StatTools is an integral part of that because we can put on a 2-day class and go over all kinds of statistical analysis using StatTools as the software. Another classes we do are these applications where we look at specific applications like portfolios or petroleum, or do cost-benefit analysis and things like that. I just wanted to show you a little project I'm working on you may be interested in. I was just recently in Guatemala. There's this little town outside of Guatemala City called Chinautla. And what I'm doing with this project there is we are modeling small farms there. And so we're going to do it in using at-risk. We're going to use optimization. So we're going to come up with we're going to take financial theory like portfolios and apply it to small farms. And so the benefit of this is going to be when we go to the policymakers, we'll be able to tell them that these farm plans don't work because this particular item in the model's thwarting it. That could be prices, that could be bad roads, that could be yields due to some pest. And so the government will be able to step in and target their subsidies in an appropriate manner. And so we actually had a meeting among the farmers, and this is a picture of a meeting. And you know, in the United States, when we get farmers together, you got to give them something, usually a free lunch. And so this particular case, they were getting free machetes to take home to attend the meeting. You can notice a lot of them are women because down there, a lot of the women are running the farms, and the men are working in the city doing something else. So anyway, let's get back to statistics. Learning statistics can be quite a chore for a lot of us. It's not very intuitive, and people have a fear of dealing with it and talking about it. And you've probably seen when you talk to people about statistics or risk analysis or optimization or real options or whatever, a lot of times their eyes glaze over. And so when you teach statistics, I teach a statistics class in the computer lab, and this is at the college here, and the entire class is in the computer lab. And so by the end of the class, they've got a tool using Excel to solve problems. And so it's not like that they walk out and forget it, because we're not doing it with pencil and paper and a calculator, but on the computer. Several good books. If you're interested in this book by Albright, Learning Statistics with StatTools, will give you more information than the stat manual. And then this Anderson Sweeney Williams book is that's a classic statistics books that includes the StatTools also. So another way to learn statistics is at-risk is a great tool to learn statistics too. Many of these tests that we use, I'm going to go over a few. A lot of them can be performed using Monte Carlo simulation as well. You know, when statistics was developed, it was before computers, and also, and so the tools for statistical inference that were used, you know, we had to do them with formulas. Nowadays, we can use the brute force of the computer to look at things like statistical significance. So that's just some food for thought. So I want to get into StatTools and kind of tell you, go through some of the features here. It does a lot of things, 37 wide-ranging, commonly used statistical analyses. And since it's in the Excel environment, we can get spreadsheets readily from other people. We can download spreadsheets from the internet. And nice thing about this is you can use other Excel functions. I'm a great fan of pivot tables. I don't know if anybody uses that out there who's listening to this, but that's a great tool, and you're going to need that, especially if you do things like contingency tables in Excel. And another thing that's very nice to have is this live updating statistics. So if you perform a statistical analysis on your data set and then you change your data set, it will automatically update your output of your analysis. And so also when we do reports in Excel, you know, we come up with graphs, and the graphs are in the Excel format, so you can change things quite a bit. Okay. The documentation that comes with StatTools, is with the software, and you can print that out, and that will get you up and running to figure out the functions. But I would recommend maybe that Albright book to further extend the applications of this. So I'm going to talk about the StatTools now. If you're using 2007, we use these things called ribbons, of course, and I'm going to talk about this Dataset Manager, data utilities, and I'm going to run through some of these features here of the analyses, and then also I'm going to talk about this little tool here called utilities. Okay? Okay, so let's start with the Dataset Manager. Now I'm going to go to my StatTools here in a sec, but before we get going there, a lot of information we get now is in Excel format. Kind of back in the old days, you had to get ASCII files or text files and then convert them. And you can convert text or ASCII files very easily in Excel. And so this is just one of the ribbons for in Excel. And so if you have this from text in the ASCII file, you can convert, or if they have an automatic thing for access too. And so if you're working in other platforms like SAS or Stata or whatever, there's a lot of StatTools, and you need to convert a database or a data set using StatTools. You can convert it to a ASCII file and then bring it into here, and that should work fine. Okay, so I'm going to go over here. I'm going to start my StatTools. So it'll take a little while to warm up here, not too long. And this splash screen comes on, and you can not have that come on if you like, but I like to have it come on, so I'm going to close that. And if you'll notice here up at the top, there's the bar here, the ribbon called StatTools. So we're going to work in on this right here. So like I said, we're going to start with Dataset Manager. I'm going to click on Dataset Manager, and what it's doing, it's asking to load something, okay? There's no spreadsheet here, so let me go find a spreadsheet. I'm going to find a spreadsheet here on my desktop. And okay, this is a spreadsheet of the passenger list for the Titanic. And I just got this off the internet, and it has, we're going to get back to this later, so I'll explain it a little bit. These are the passenger names right here. This first column right here is the class, whether you went first class, second class, third class, or whether you were a crew member. And this, where it says survive, this is what we call a discrete choice. 1 means that the person survived, 0 means they didn't survive. And so we have a lot of attributes over here, like the gender, age, and even how much they paid for the ticket. So if you go down here, John Jacob Astor and his teenage bride were on there. Molly Brown, who was from Denver, the unsinkable Molly Brown was on there. And if you even go down further here, we have the owner of the Titanic was on here too. And he's Wright Ismay, the owner of the White Star Line. Let's see if we can find him right here. He actually survived. Okay, so you bring in your database, and regardless of what it is, and you just click somewhere in your database, and you go up to Dataset Manager right here, and you can give it a name if you'd like. There's been a name in here already. And so what we have here now is the variables are in columns. A lot of times not a lot of times, but sometimes we want our variables in rows, especially if you have some sort of pro forma spreadsheet and you want to do a statistical analysis going horizontally. And so this should be okay, and it says the Excel range is A1 to N1310. And you ought to check that because, just to make sure that it's capturing the entire database. So I press OK. And then if you go up in here to the name box of Excel, you can see that it's highlighted these things. Okay? All right. So that's kind of how we start the process. So I'm going to close this out and just open up another one so we can look at another data sheet. And let's look at this one. We're going to go from that Titanic to log data. And my background's in agricultural economics. So in ag economics, you do a lot of work with commodities, and you look at supply and demand curves, and so I want to explain some of the data utilities features using this. This is what we call time series data. We have data from 1960 all the way to 2006, and so these are like number of pigs slaughtered, the price of the pigs, and these are the price of the inputs that the pigs eat, okay? And so, when price of inputs of feed go up, less pigs are produced because it costs more for the supplier to do it, so he's less likely to supply those pigs. Okay, so what we do, I'm going to go back to Dataset Manager. I'm going to add that in. That's the interface. And then I'm going to go up to Data Utilities here. Okay, let's look at these guys for a sec. What the data utilities do is sometimes when you get data, you want to stack it or unstack it. And really unstack means if your data is in one long column and you want to break it up into several columns, you can do that. The other thing that we like to do is do transformations. And a transformation, let me just click on here and let me show you what that's all about. A lot of times in time series analysis, we want to change things to natural logs. So for instance, if I want to change the pig price to a natural log, I'm going to click here, and you see the function here is we're going to use log, but you can also square things. Here again in time series or regressions, you like to square a variable also because you want to take something that's kind of non-linear and make it linear. So I'm going to press on log here. And as you can see, it puts it over here on this column. So remember the pig price was $15.96. The log of $15.96 is 2.77. That easily does that. Let's look at some other utilities. How about lags? A lot of times when we do lags is we want to lag a certain variable when we do regressions. And so I want to see what the impact of a variable that happened a period ago is today. And so if I do pig price again, and I lag it 1 right here, press OK. Let's see what happens. It puts my lag price over here. So this price of $15.96, we're saying it's in this period, but actually it was last period. So that's a very common thing to do. And they're called distributed lag models. When you lag, you try to predict what's going to happen tomorrow by lag prices. Differencing. That's real important also. When we do time series, there's a problem if you have non-stationary data. And non-stationary data is essentially data that may be going up all the time or down all the time. Maybe it has a trend to it. And so what we do is we have to take a first difference of that. And this is a tool that will allow you to do that. And so when we do first differences, we're not really looking at the actual values. We're looking at a change. So let's see what this difference does right here. See that value right there? That is simply this value minus that value. This value here is simply this value minus that value. So that's the first difference. Okay, let's see what else we have in here. Interaction. That's commonly done also. When you do a regression, you may want to have variable A and B, let's say, as your independent variables, but you also want to have the interaction between A and B. So that is just simply multiplying A and B together. And so if I want to, not that I really want to do this, if I want to multiply pig price and corn price together, is there an interaction between them? I press OK. And over here it'll multiply for each year the pig price times the corn price. Okay, let's see what else we have in here. And you can also make, on this transform command, you can make your own, do whatever you want. So for instance, when I wanted to do real pig prices here, I had to put a little formula in here that you can see right here. And that little formula right there, you could use in that transform command. Okay. While we're right here, let me show you this little utilities bar right here. And there's something in here called application settings. This is kind of the master control area. So, for instance, remember we had that welcome screen that came up? If you want to turn that off, you can simply go to here and turn it off when it comes up. Also, if you want live updating, you can turn it on or off right here. And so these are some of the things that you may have to go through. What's kind of nice, though, is you see these comments? It has these educational comments in here. And especially when you get into statistical inference, a lot of times we deal with these null hypotheses and p-values, and you don't. Sometimes you forget. Well, what does this mean? I see a number here, but how do I interpret it? So that's where you do that. Okay. So I'm going to save that. And let me show you one other thing that's real useful as far as data utilities. I'm just going to close this. And I'm going to open up another one. This is we're back to the Titanic, but this is kind of a simpler one. It's simply, these are the IDs of people, whether they survived or not, their class, their age, and 1 if they're a woman and 0 if they're a man. So I'm just going to go in the Dataset Manager. I'm going to add that. And then I'm going to go back to Data Utility. I'm going to do these dummy variables. Okay? So watch what happens when I click on class. And the captain has to move over to the right. That's Captain John Smith. And you see this class right here. This class had 4 categories, 1, 2, 3, 4. And what it does, it makes dummy variables of these real easily. So for instance, person 1 has an ID of 1. They were in class 1, first class. And so a 1 goes here and a 0, 0, 0. Person 2, class 2, a 0 goes here and a 1 goes under the class 2 column. So this is real important to do when we do the these regressions. So let me just close out of here. We'll go to another spreadsheet. Okay, let me pick up another one here. Okay. We'll play with this one. I'll show you some features in StatTools. This is the cars that were made 30 years ago. And so we have the makes over here, and we've got the price of the cars, miles per gallon, different attributes. So when you start your data analysis, you want to start out with summary statistics. So let's see what we can do with that. Okay, so I open up my database, and I'm going to go Dataset Manager. I'm going to add to it. And you don't have to do this each time. I just kind of start out with a clean sheet all the time, but you can store that in there so StatTools knows that that's your data set. And then I'm going to go to Summary Statistics. And I'm going to click on one variable summary right here. And I'm interested in miles per gallon. So I'm going to click right there. And you see these are my statistics that I can have show up here. So I'm going to press OK. Now, where you want this is this little box comes up. That was in that utilities part up here that I said prompt me for where to put it. Or if you want to put it on a new worksheet, you can put it in that utilities dialog box and it'll put it on a new worksheet. I like to keep it on the same worksheet where I can see what's going on. So I'm going to click right here and then OK. And so what it does, it gives you statistics here. For those cars, the average miles per gallon 30 years ago was 21.29. And so all your different statistics. Okay, what else do we have in here? Summary statistics, we can do correlation and covariances. So I'm going to click on that. Okay, so let's say I'm interested in looking at, is there a relationship between miles per gallon and weight? I'm going to click on those two right there. And then I'm going to say I want a table of correlations and a table of covariances. And this is your table, like if you want data on both sides of the diagonal, but I only like to put it on one side, but you could have it on both. So I'm going to click right there. Press OK, and I'm going to put it over here to the right somewhere. And over here, it gives you a correlation table. So the correlation between miles per gallon and weight is minus 0.807. So that says when the car gets heavier, the miles per gallon goes down. So that's quite a big correlation coefficient. Down here's the covariance. This is the variance of miles per gallon, which if you look right over here on this table, they're the same thing right there. This is the variance of weight right here, and this is the covariance between miles per gallon and weight, which is analogous to that right there. They're both telling the same story. Okay. All right. So what we also do is when we do this, start out with our data, we like to look at statistics, but we also like to look at graphs of the data. It's people call it exploratory data analysis, is just to get a feel for the data. And so what we do is we can go up to this right here where it says summary graphs. And histograms are used quite a bit. So let's click on a histogram. And here again, I'll click on miles per gallon. Or let's try, let's do miles per gallon. And I'll press OK. And I'll put it over here on the right somewhere. Put it right there. And this gives me a histogram of miles per gallon. So for instance, let me give you a better shot here so we can see this. So for instance, this table up here is called a frequency distribution. And we take this data from the table and we graph it. And so these are our bins, for instance. The first bin is going to have the miles per gallon between 12 and 15.625. And there was 10 cars there. This bin is between a certain interval, and it has 25 cars. So you can look at your miles per gallon or whatever you want to look at it and get a feel. What's good about this, and we'll talk about it in a little bit, is you can kind of see is the data normally distributed. And that's real important because a lot of times we assume normality when we shouldn't. And so this is kind of a first cut on that. Another graph you can do is, on these summary graphs, is we can look at a box whisker, and we don't use these too much, at least in the business world, but in other disciplines they are. So if I clicked on this box whisker, you've seen these probably. What's nice about the StatTools is that it gives you what all the box means. You know, like that's the interquartile range or whatever, and there's the mean and there's the median. So that's nice to put that down there because since we don't use these as much, as sometimes it's hard to figure out what goes where. Another thing we use a lot is these scatter plots. Okay? So I'm going to do a scatter plot. I'm going to say, okay, let's say I'm going to make my y variable miles per gallon, and I think that's a function of weight. All right, so I'm going to make the y miles per gallon. I'm going to find weight here, make that the x, and press OK. And here again, this thing's getting kind of busy over here. So I'll put it right here. And we come up with a scatter plot. And this scatter plot right here is shows a relationship there. It shows a negative slope relationship. And the nice thing about doing this in the Excel environment is if I click on here, this is an Excel chart. So I can do things like add a trend line in Excel. But watch what happens when I do this. I've added a trend line here, a linear trend line. Here's my trend line equation, and here's my R² value, or the goodness of fit for that. And so that's a real good tool. Okay, so I'm going to close all this out, and we're going to talk a little bit about statistical inference right now. Okay, so let me go back to my PowerPoint here. Went over these things, summary stats, the graphs, and the statistical inference. So let me spend a couple minutes on this, and then we'll run through some examples. Statistical inference is if you go out and poll something, who's going to win the election, we go out and take a sample, and we want to be able to use this sample to infer that everybody behaves like that. And so we do experiments out there, we take polls, we do regressions, whatever, and we're really only dealing with a sample of the population. So really what we want to do is we want to say, okay, how confident am I that by just looking at a small part of the data, how confident am I that the population behaves like this? And so in the statistical inference tool, we do all of these hypothesis tests like T-stats, that's included here. ANOVA we do when we're dealing with 3 or more samples. And chi-square tests we deal when we're dealing with counts. And so the thing about statistical significance, if you have a big difference between two groups, you'll probably find statistical significance, even though the sample size is small. Again, if there's a small difference between the groups, you may find statistical significance because the sample's so big. So you have to be kind of wary of these things. And so when we do these statistical inference, we use the null and the alternative hypothesis. And so it's all about hypothesis testing. And so a lot of all these stats tests we use, we have to go through this routine. So the null usually says that there's no difference between the groups. The groups are the same. The medicine doesn't do anything. The alternative is there is a difference between the groups, or the groups are not the same. That is, the medicine is effective. So what we do is we try to reject the null and accept the alternative. And we can never say that the medicine works with 100% certainty because the results could have been by chance, so we report, for instance, we're 99% confident that this occurred not by chance. Okay, so let's just go through, here's one we can look at. Do magnets help alleviate pain? So claims have been made that the magnetic fields can affect plants and animals, okay? And so this is from a journal article, and I got the data. And so they did an experiment, and let's open up the data and see what it looks like. Okay. Okay, I'm going to get rid of this right here. This is kind of interesting, you know. These were polio patients, and this was their pain score. It went from 0 to 10. 10 was in a lot of pain. And so they applied magnets to the area, and this particular patient here had a score of 0 after the magnet, so the pain was gone. So the change in the pain was 10. And so we had two groups here. We had these people actually got the magnet, so active treatment. If you go down further here in the database, these people, it says 2 was a placebo. So this person started out with a pain of 8. After the magnet, the pain was reduced, and so the change was 4. So there's a lot of different ways of doing these problems, you know. Just for the sake of explanation, I'm going to look at the differences between the pain reduction of people who got the magnets and people who got the placebo. So I'm just going to start right in here. Okay, go to StatTools. Go to Dataset Manager, and I'm going to define this little subset as my data set. And you see how I've been playing in here before, so I'm not sure what's going on here, so I'm going to delete some of these. Just to get them out of here. And then I'll just go back in here again and try it and do it again. Okay. Well, let's see. We'll just use this data set 3. Let's see where we are here. Okay, that we can use that. Okay. So F3, we're okay. Press OK. Okay. Now I'm going to do my statistical inference, and I'm going to use this one called hypothesis test for this one. Okay. And so when we do these t-tests, there's paired samples, but this is actually going to be a sample analysis. Okay. And watch what happens when I press OK here. what it does here is it puts my scores over here, and so we're really interested in this t-stat right here and the p-value. And so that p-value is, I can say that I'm very, very confident, or 0.999% sure that this result didn't occur by chance. So we can reject the null. So that's what it's telling you right here at different significance levels. And so it also gives you, when you do these tests, you know, is there equal variance or unequal variance, and there's different tests here for that. Okay? All right. So that's one example on the magnets. You can also do these non-parametric tests right here. What happens is a parametric test assumes normality. And so what I mean by that is it has to be normally distributed. And sometimes things aren't normally distributed. So you can go here and use these non-parametric tests. And really what they're using the median instead of the mean. So they're testing, are the medians different? Because, you know, means are real sensitive to outliers. And so if you have one piece of data that's way out there on the outskirts of the central tendency of the data, it can really mess up your results. Okay? Okay. So that we could run one of those on there. Okay. A chi-square test. Let me just do a chi-square test really quickly. I know we don't have a lot of time to do this, but chi-square test is count data. So for instance, you've got a crosstab, and you make these in pivot tables. This is how you make these, and you want to say, I've got 3 regions: Western, Northern, Southern, and I got people enrolled in school, yes and no. And so in the Western region, I've got 8 people, and there are 5 enrolled in school and 3 aren't. And you want to see, are there differences among the different regions? So this is what we use here. Are the 2 variables, are they independent? And we want to reject that and say that they are dependent, that this classification scheme is, you know, there are differences. So to do something like this, I would go to Statistical Inference, chi-square, and it's asking me for my table. So you block your table and press OK, and I'll put it right over here. And what happens is it gives you original counts and also expected counts, and the chi-square down here is right here. That's your chi-square value. And I actually figured it out by hand over here, so it came out to be the same. And so the p-value here, remember, if you forget what that means, a low p-value is evidence that the row and column attributes are not independent. So we can reject the null and say that they are dependent. Okay. While we're with talking about normality, let's remember I said when we ran some of those tests, you have to assume normality, or if they're not normal, then you go on to a non-parametric test. Let me just show you what I mean by that. How would you detect non-normality? This is a little spreadsheet here. And these are years here, and these are wheat yields for dry land wheat in eastern Colorado. Okay, so we've got, in 1986, it was 37 bushel average, 1987, 40. And so what we're going to do here is I want to see, is this data normal? because if it isn't, I may want to use some other tests. And of course, you know, looking at normality of data, if we assume data's normality and we take a mean and the standard deviation, remember that 68% of the values are between two standard deviations, you know, a -1 standard deviation, a +1 standard deviation. That only holds when something's normal. So we should really have to be careful when we use standard deviations and if data is not normal. So I'm going to go up to Dataset Manager, go yes, go yes. And the first thing to really look at whether something is normal is you can always go back and do a graph, do a histogram, just to see what it looks like. And, you know, does that look normal? Not really, because look at this bulge here. And you can really change the shape of it by putting a different amount of bins in. But let's go into one of the normality tests up here. Okay? Let's look at this chi-square test. This is the same test that we used on the preceding problem when we did the chi-square. Figure it out exactly the same. So I'm going to click on chi-square. I'm going to click on bushels. And I'm going to put it over here, right there. Okay. So let's see what this thing is. And you can change the bins, of course. But if this thing were normally distributed, you see the purple here? That's what it would look like. Our actual data, which is the blue, looks like this. And so it's really not normally distributed, and there's a test here, right here. Okay, p-value. What's it say? The null hypothesis is that data are normally distributed, so we can reject the normality pretty much and say that it's non-normally distributed. Okay? And so there's some other tests up here too, as far as normality goes. I'm not going to go in there, but you can look at those. Okay, let's go on to another little problem here, because we're kind of running out of time. And let me open up something else. Okay, let's look at, let's go to this, we'll go back to the Titanic. Okay? And I want to do a little regression here, okay? You've got, up in the regression tab here, there's 3 types of regression you can do. You can do a regular regression, you can do a logistic, and you can do a discriminant analysis. And I just want to show you what logistic regression is all about, because I think it's a real powerful tool. So let me get back to my slideshow here. Okay, so this is what logistic regression is all about. These are called discrete choice models, and so the dependent variable is discrete. It can take on 1 or 0, okay? And when 1 means something happened and 0 means it doesn't. So in that Titanic example, 1 meant they survived and 0 meant they did not survive. And so when we do these regressions, it's really a good thing to use in economics or in the business world, because here's some examples down here. Do you buy Pepsi or do you buy Coke? Do you ride the bus to school or do you drive? Do you attend college or don't you attend college? So what we want to do is we want to find what the attributes are of these decisions that people make. Okay? So let's do this on the Titanic model. So I'm going to go back to the Titanic model here. and I'm inside here. And I'm going to go up to Dataset Manager, and I'm going to add it. And then I'm going to make some dummy variables. We've already done that, but I'll make them again. I'm going to make them for class. Okay, so this is my problem. I want to look at the people that survived and didn't survive. And I want to see if I can predict the people that survived or not. So for instance, whether or not they survived, is it dependent on the class they were on? You know, did first class people survive more than the third class or the crew? How about the age? Were younger people more likely to survive or older people? How about if you were a woman or a man? So what we do for this is we go up to regression, and I click on Logistic Regression, and then I say, okay, my variable on the left side of the equation is survived. That's a 1 or 0. And then I'm going to say, okay, let's look at age, whether or not they were a woman, and we'll put the classes in. And so when you do these dummy variables, you have to exclude one of them. So I can't put them all in or it won't run. Okay? Okay, so I'm going to press on OK and see what happens here. Now let me just put it right there. Okay, so we've got these. We've got this over here. So let's look at our results here. Okay, so when we do this, it looks like kind of a regression equation here, but let's look at it and just look at some salient things. Okay, this up here is the significance of the overall regression. These are my coefficients for the different variables. So we're really interested in this right here, okay? And so let's look at this. Let's look at the biggest one, 11. So what that means is if you increase the age by 1, the odds of surviving increase by 11 times. And so this is a real big impact, being a woman. How about age? What that's saying is the older you are, the less likely you are of surviving. And we've got the classes. Look at the class. You are more likely to survive if you were from first class. You were a little bit more likely to survive in second class, but you were a lot less likely to survive if you were in third class. And so we look down here, and this is the model's really good at predicting the people that didn't survive, and it's not real good at predicting the people that survived. So that's the 50% of the time it does it right for the people who survived. 91% of the time it does it right for the people that drowned. And what's kind of neat about this, I can go down here and remember person 1, age 17, a woman, first class. And the original class means they did survive. And I'm predicting with 96.31% probability that they survived. So that was a true prediction. And some of these, like you scroll right down here, original class, that's a 1. They did survive, but we predicted they didn't. So that didn't work out too well for that. So we're getting really out of time here, but I just want to show you one other thing that I didn't touch on. If you're into Six Sigma, the quality control analysis up here, for statistical quality control is right here. And also you can do regular regressions or discriminant analysis regressions. I've kind of covered everything maybe except those two. So, Jameson, if you're still with me, I think we're about out of time.
Well, this was great.
Okay.
Thank you.
Sure.
And let's wait a minute or two for more questions to drift in.
Okay. I know it's kind of a whirlwind tour, but you know, you can do this in a whole semester at college, so.
Yes, I could see that. Oh, and then how about those 1978 cars?
Yeah, and that's kind of fun.
That's fun. You know, the Le Car. There's one a few blocks from here with some blackberry bushes growing out of it.
Oh, really? Yeah, that Volkswagen Rabbit diesel was getting 41 miles a gallon then.
Still on the road, some of them.
Yeah, they were kind of a neat car.
Well, one question here, will this be available to watch in the future? That's a good question. Yes, we're going to archive this on our website, and I'll gather the emails together of the attendees, and I'll send that out as a reminder. The link to this presentation will be in the email, and that'll take you right to our website, and they can be watched for free forever.
Sure. And if people have questions, you know, you can drop me an email. I'd be happy to respond.
Oh, sure. And
call me, whatever.
I'll include your email then in my reminder.
Cool.
And let's see. We'll just wait another minute. Well, maybe if you folks out there think of any more questions, just email me and I'll forward them. And then John's email will be in my reminder that should come Monday or Tuesday. I think we'll be able to archive the webinar by then. Cool. I want to thank everybody for attending, and thank you, John.
Thank you, and thanks everybody for participating. And talk to you later.